Alright everybody, we are live again today with part 2 of the CNC machine that I'm going to be designing in Blender and actually trying to create in real life. Now, we left off where we were trying to get the axes all set up, the frame was coming in together pretty nice. I did get my spindle motor in. Matter of fact, I could show you real quick what it looks like. It's one of those Chinese hobby motor, you know, one of those 24 volt maybe. I don't know. It's weird. It's one of those cheap Chinese ones that you can get off Banggood. Came in this box. I didn't do like an unboxing or anything, but I'll just show you guys what that spindle looks like. Okay. So here you got it. Try to get that in pretty good. I know it's probably hard to really see with you guys having such a small screen of view, but it is what it is, so just gonna have to bear with me here. So yeah, it's a nice little spindle. I like it. It does what I need it to do. And it came with this shaft that you can use that slides on, and then it bolts, and then it has, like, you know, gaps so it can tightly fit on there while you're bolting it down to the machine. Came with a spindle controller with variable speed using a potentiometer, so that's good. It's in here. I can show you really quick for that. Pull that out. So it has the potentiometer here. It's pretty big. Nice. Get a little closer here. If that zooms in, there we go. And then we got, you know, a little power supply, adjustable speed, variable adjustable speed going in. And then that little red jumper wire right here is basically like a switch wire. It's connected because it allows, once you plug it in, it automatically gets power to it. And adjusting the speed will bring it down to 0, or like whatever the speed is. I think it's like 15,000 to 20,000 RPM, something like that. But you can actually just remove that wire and actually place like a regular flip switch, so like a toggle switch or something. So you have that available. But yeah, so I got that in, I would say, earlier this week on Monday. So it came pretty quick from Banggood, to be honest. I was expecting it to take about 2 to 3 weeks. And that's for me. Now, you guys, wherever you're located, if you're in the United States somewhere, it may take longer because, well, I live in Florida, so we don't have like a whole lot of different, I want to say, cities or not states around us that blocks traffic. So like, you know, if you're in the center of the United States, let's say like, I don't know, Arizona or something, or like Utah or something, you know, somewhere dead center where you have to go through a bunch of different states to get to where you're at. I just feel like we get our stuff a little quicker because all we have is, you know, the seas around us. So they literally just fly overseas, land like Orlando or Tampa airport, one of those two, and then just come straight here for the most part. So we don't have to worry. I personally don't have to worry about my stuff taking too long to get here. So that's good for me. But anyway, so we left off at that part where we're getting the table and everything set up. I did start designing the spindle when I got it. I didn't put that on there, but it's one of those things where I know I'm the type, if you're anything like me, I don't like the fact that when somebody is showing something on Blender, step-by-step process, that when they get done with a part video, they start working behind the scenes, so then when they get into like part 2 or 3 or something, then you wind up having to figure out what they did that wasn't on camera. So I didn't want to do that here for you guys, but I didn't really have too much of a choice. It isn't too bad though, because like it's not hard to do, to be honest. So I'm not trying to, like, you know, what do you want to call it? I'm not trying to make it sound like I didn't do something wrong. I am sorry that happened. And so, you know, just take it with a grain of salt here. But here goes the design. I got the spindle kind of designed already, made it black in color. And then I measured out one of my, call it the drill bit slash, you know, flute, whatever you want to call it, the mill. And so I measured like half of it, so this would be the other half. So basically when you put it inside of the collet, inside of the machine or in the motor, spindle motor, there will be half of it being used and the other half will be sticking out. So in here there will be half and then the other half will come out. So what I did was just measure out half from this point to this point on my on the bit, and that's the real length right here of the spindle and everything. So this was pretty quick of a design. It's not like I try to tweak it up to make it super amazing looking or anything. It's just something to kind of see where I'm at when it comes to the size of the spindle, so we can know where everything is in our XYZ plane. And yes, I did bring in the other rail bearing pillow blocks. So you got this one right here, this one right here, this one right here, and this one right here. So we have all four. And like I said, all this aluminum excursions that I have on here for the frame, I pretty much already have these pieces. So I was able to kind of just measure off what I have and then see what I need to buy, basically, is where we're at right now. So I have this build plate aluminum. I have these rails for the most part. They're longer than this. I would have to cut them using like some kind of saw with a metal cutting blade on it. Most likely it'll be like a black circular granite looking disc thing. I don't really know the name or the terminology for it, but it's looks like a solid little thin brick that can cut through it. So I used it before, so I know for sure it'll work and cut through this metal. It takes like, maybe 2-3 minutes, but it'll get cut through without any issues. Then let's see, this I just brought in too. I don't think that was on the first part of my video. That's just one of these pieces right here that I just duplicated, rotated to 90 degrees in this plane view. So if we did that, it will be super simple for you to do. And then I was just trying to see if this piece, this 20 by 40 excursion, would actually do well for us mounting it to the spindle to this part. But I'm not sure if I'm gonna go with that. I may have to like order a complete railing system, or really lately I've just been thinking I may not even really go with all this. I may just design one completely from scratch using aluminum plates and drilling out the holes, tapping the holes, countersinking it, all that stuff. But I felt like at first I wanted to do this way, but I want to make sure I'm having a lot of rigidity. I don't want to have, I want to make sure there's a lot of tolerance, no play, no wobbling, nothing like that. And when it comes to the excursions, they're okay for 3D printing, but they're not going to be the best for like trying to mill out aluminum or anything like that. So I may still use this machine if I decide to go with it, but honestly I'm thinking about just redoing everything and just starting off with like a regular milling machine, kind of like all from scratch. Now I looked up a few that some people have designed, and they're really nice, like, and they probably cost them a fortune, like at least $8 to $1,000. But I honestly am not sure if I want to go with most of their information, because they used it for certain reasons. I'm trying to do more milling of like aluminum and cutting out plexiglass, because I got a lot of plexiglass already kind of like laying around ready to be used, and I had so for quite some time, so I'm kind of itching to get this plexiglass cut up. And then I was thinking, like, in the future, I like anime a lot. I don't know if you guys are into any of that. If you are, definitely check out my videos, because I've already done some stuff that has to do with DIY anime based stuff. But in the future, I wanted to start designing CNC computer cases, kind of like I wanted a CNC like a complete computer case with like anime characters embedded into it. So like Luffy from One Piece, Goku from Dragon Ball Z, Super, GT. Then you have all those other characters from like Naruto and the works. So I really want to start doing that here in the future. So like if I did like a front part of a computer case, where it has that plexiglass that you can see, not the front part, but the side part of the computer case where you can see into your case. I was thinking about like engraving a picture of like an anime character or something along those lines. And so for that, I want to make sure I can cut out the piece or definitely engrave it at least. And then if I need to make the whole computer case aluminum or some kind of material, maybe like carbon fiber, something like that, that would be pretty amazing. I want to be able to cut that stuff out with my machine, and honestly, I just don't think this machine can do it. Even with the better spindle than like the one we were talking about here. This, not that spindle. Yeah, this spindle right here is the one that I was just showing you. So that one did come in. I meant to say this one. Hold on, let me hide this picture or bring down the opacity on that, and then we'll bring up the opacity on this one. So see here, if I hide everything really quick, this picture shows my spindle, my the CNC that I was kind of looking at that to design for. And I mean, it's good. I've seen somebody cut like an aluminum plate out of it for like electronics LCD screen or something, but honestly, I didn't like it already, like I was talking about in the first video, because it has a lot of 3D printed parts. So the rigidity of this machine, I feel like it would flex way too much. Even if I did like 100% infill, and say with some high tolerance filament like ABS or PETG, nylon, any of those, it would still sort of have a movement in it compared to steel or aluminum, any kind of metal. So there is ways around some things. I had gotten some information around CNC this last week. I've been doing a lot of research on it, but sort of for the most part, I'm not sure. Like I'm still debating, but we're gonna continue where we left off at, so that way you guys can kind of follow along. Really, this is one of those like design slash course type of information to design whatever CNC you want. Obviously this machine may not work for me, for my situation that I'm trying to do, but everybody's situation is different. If you want to build a bigger, say, machine than the one that I was just showing a second ago, this one right here, and you're trying to like you decided you were gonna get that, but then you're like, well, no, I need something bigger because I'm milling out, say a bigger PCB or something that you're designing for like a project or something. You need something bigger. So this right here would work. Like this for sure would definitely do it, especially if you're not running too fast back and forth. So I'll continue designing this one for right now. Then once I'm done doing this, I'll go ahead and stop the video, start another one. It'll be pretty much like a back-to-back thing of me doing another CNC machine that I'm going to design completely from scratch. And then we'll go over like part list and information about it, and see if we can find like the parts on Thingiverse to help bring them in to Blender, so that way we can kind of I want to say mirror the information off, so we don't have to waste so much time trying to design every individual part. So anyway, so let's go ahead and get into it. We're still in orthographic mode where we left off at. Like I said, I brought in the spindle now. That was just a cylinder that I manipulated here and there to bring cylinder in, and extruded outward, extruded inward, outward, then inward again, extruded down. That was pretty much it. And then let's see, then we brought in the deselect. Then we brought these guys in. I only had one at the time that I ended the video, I remember that, and then I just duplicated, dragged it over to the other side, and then duplicated, dragged that one backward, and this one to the forward. But what I didn't show you was I was measuring out how this was going to work. So what I mean by that is the bed plate needs to make sure that it doesn't hit or fall off the rail track, right? So what I did was just click on the individual blocks, the bearing slider. So you have that one. I'm going to have to zoom in a little bit so I can kind of grab them all. Go here and touch. Zoom out, zoom in, and then touch. And then we'll move over and touch and touch. So now we have all these selected by holding shift. Oh wait, I don't have my bad, guys. You guys can't see that. Text editor. I know that I don't have to. I can. Oh wait, no, I run script. I was gonna say is that I didn't know I was gonna have to run the script every time to start my screen display. So I'm sorry. But yeah, if you hold down shift and then you click on it, you'll see that it's being clicked. So, but so yeah, we got all these grabbed. So what I was doing was trying to make sure that these blocks didn't fall off the rails. So if we get out of wireframe mode here by hitting Z, you see right here there's an end. You know, your tracks fall off at a certain point. So we don't want that to happen. So what we're gonna do is we try to position the blocks where it'll meet the spindle motor in the center. That gives it enough travel space to be able to get to all ends. So we have to make sure we get on this end here of the table, this end here of the table, and this end, right? So the Z-axis will be able to move back and forth because this spindle motor right here can move, you know, all the way over here where if it's homing, and so it has plenty of travel space in between that gap there. We actually can go off of that end piece. So all we have to do is actually make sure that the bed can travel back and forth without bumping or sliding off of the tracks here. So what I did was I was positioning it with this and this part here, so I had to move my gantry front and back just to make sure I was able to find it. But how I started it off was I moved these spacers first, the not spacers but the slider bearings blocks. So I positioned these about, what was it, I think 8 millimeters back from the end of the table, so, or the bed, whatever you want to call it. And so I pushed them both in the same direction, like the same way. So this one was 8 millimeters this way, I believe, and then this one was 8 millimeters, or like 10. I don't know if it's 80. I think it may be 80 millimeters because I was far out enough to and do the increments in 10. But anyway, I made sure that when we move this together, it gets up to right here, and then you can see that we won't slide off the tracks. So if we show, if I can get to the side here, zoom over here, let's do side view. So you can see right here we're barely touching the end of the track. So right here, that won't allow it to completely fall off is what I'm trying to say. So it just barely gets over there. So that's good. We're not off the track. It's just like a little, like maybe, I don't know, 2, 3, 4 millimeters off or something. But it's not completely off the track or anything like that. And this is way far out. You can see my spindle motor, for instance. You see this circular part right here, the center? This part is actually the shaft of my spindle. So if we went down, this is the shaft right here that's going to be milling and cutting out everything. So if the table's right here, this red line, that means we passed the end. So literally this can go off of the table track, which is good. So, you know, in G coding and everything, once we get the firmware in for like GRBL or whatever design firmware we're trying to use, like we can use Merlin if we wanted to. That's a 3D printing software or firmware. So we have, you know, a few options available, but we'll have to just implement the code information to make sure that we don't travel off of the bed here. But it's a good thing that we can. So say we don't want to do that, and I just move it to the exact end of the bed here. I'll have to zoom in a little bit to do that. Move. Let me see if that did it. That was a little too much, but you get the picture. If I just move like that, it'll be just fine. But so then if we move forward, you know, I had to make sure I position everything right. So we want to make sure we move forward. That won't fall off these tracks here either. So I move forward, and then say we bump right here to the end of our aluminum excursions, and you can see that we're a little off right here, just a tad. So I may have to move this gantry back just a little bit, but it definitely will work. It's just because I just imported this one in. Now if this part right here, this 20mm part, wasn't there, then it would actually have mounted flushly, but we're gonna have stuff here, so I don't know, like I'm trying, like, basically what's going on is we're gonna have other parts on here, and I'm not sure how fat or wide pushed out this part would be. I mean, there could be two of these pieces pushing this forward, then, you know, we have to redo it again. But I was just trying to get a good estimate information to start off with. So, but for the most part, we can move our y-axis left and right now. I mean, front to back now without any issues. And for sure, the x-axis has plenty of gap in between the tables here and here, to where we can actually make sure we're milling off the, you know, all the way to the edges of our platform. So now that we have that, the only other thing I had to bring in was some stepper motors and lead screws. I don't know if I can find a lead screw or not. I'm going to double check on Thingiverse here in a minute. But we need to have a lead screw, so I'm going to show you the picture. Let's just hide everything again. So right here we have a plate that's holding a stepper motor. Now this is a NEMA 17 stepper motor. This one and this one up here. But I have NEMA 23 stepper motors that I'm going to be using. So they're going to be a little different, and basically it's just going to be a little bit bigger. So the brackets that we have to make are going to be bigger than that as well. I already ordered some brackets off of eBay. They're coming from China, so it's going to be a little while. Actually, I seen that it should have arrived in New Jersey, I believe, already just today. So I should have it within, I want to say, maybe, I don't want to say tomorrow, maybe by Monday or Tuesday or something. But what I was trying to get at is we still need to obviously design it into Blender so we can know what we're working with here. And then, you know, this is an 8mm threaded lead screw. This is generic, simple, cheap Chinese one that all 3D printers pretty much use. They use it for the Z-axis travel that moves the printers up and down. So if you have like a CR10 or Ender 3 or an ANET A8, any of those have a lead screw that goes up and down, and that's what this one is. So you know for sure it's a 2mm pitch, I believe, between the lines, and then 8mm thickness for the circumference, and then there's gonna be like, oh, I don't know why I did that. There's gonna be like a lead nut, like a T-nut is what it's called, inside of this to push this back and forth, because the nut is what's spinning and that's what's pushing this back. That's the only thing that's really moving, other than this rotating, you know, clockwise and counterclockwise. And then at the end we have a pillow block bearing, kind of. It's not a real one. They use a skateboard bearing with a 3D printed holder. That's ridiculous, but it works. I'm not going to say anything bad. It works, but I'm just not comfortable with using 3D printed parts for something of this sort. But so you have another one right here. So basically all it is a holder part that holds a skateboard bearing, basically that holds the rod in place, that allows it to spin without messing up, and it rolls smoothly, basically. So next we're gonna go ahead now and start looking into Thingiverse. I don't know why I was about to say Tinkycad. But in Thingiverse here, I'll go ahead and bring my Thingiverse up really quick. You guys can't see this because I'm only showing the Blender window right now on my streaming stuff, so it's not a big deal. I know you guys know how to get online to Thingiverse. So let's see if we put in 8mm lead screw. Maybe that will do it. see if that does anything. It's loading. I don't know why Thingiverse sometimes loads kind of slow, even with me having like good internet connection. See, maybe lead screw then. SCREW. Yes. It didn't pull up with anything for that one. So yeah, it has. I found right now. I'm looking at T-nut lead screw for a T-nut for the. It's called T8 for 8mm. They have that, but I don't see like a legit designed lead screw, so that's not good. Lead screw upgrade. I'm not seeing anything. Let me put in just 8mm. That bearings. No. Then they have coupler. No. I don't know, guys. We may have to just. I mean, we don't have to design the whole lead screw, but I mean, I know you could do it in Blender. I just don't know how I would go about that. I'm pretty sure the process of learning it would probably take me a little while, so I'm not even going to worry about it. The quickest way for this will probably just be me making a cylinder with a good amount of vertices on it that allows it to be really smooth and thinned out. Well, here goes a 8mm screw. We can probably use that, but it's not going to be the right grooves because it's like a regular screw. But honestly, I mean, it's not like it really matters. I was just about to do a regular 8mm pipe looking thing, so it's not that big of a deal. Yeah, I don't see anything that has to do with that, so we may have to just get that screw that I've seen. So I'm scrolling through right now still, and I still don't see anything that'll work for what we want. So let's scroll a little more just to see if I find anything that'll work. What is that? Nope. No. So many people made, like, you know, couplers, which is great, I guess. I just know I'm not using any of these couplers for my machine. Now, if this was just a regular 3D printer machine or something, then yeah, why not? It's not that big of a deal, because I mean, sure, you're trying to get, you know, accurate prints if that's what you're trying to go with, but there is a lot of differences, I guess. I don't know how to explain it. I kind of have an idea, because the people, they designed these lead screws, right? So the T-nut that they're designing has the grooves already set up. So if we go in and copy their design, and like not copy but bring it in, we can actually take out the overall shell of the nut and then just have only the grooves. But I don't know how well that's gonna do when it comes to the innards, because yeah, I don't think I'll be. I don't know. I'm trying to think of a way to use it, but I don't know if I'll be able to. So like we could copy the vertices and everything, but it'll still look flat, I think. It won't, like, because we have to rotate outward of the grooves, so that way you'll have like the nuts basically, or the bolt grooves. So yeah, I'm not sure. I'm just gonna go with that 8mm nut that I seen earlier, since I can't find anything that has to do with that. It's just because the 8mm rod has certain type of groove on it that allows it to move freely and smoothly when it's being screwed in. It's not a normal regular grooved bolt or anything. It has its own special like cylinder-ish look to it. But so I'm just gonna go up, grab that really quick. I may have passed it. Hold up. No, that's not it. Keep going. So I went down quite a little ways here to try to find this stupid nut. Or bolt. Or rod, whatever you want to call it. Where are you? Come on. There it goes. Okay. So grab this one. Then we can just extend it to however we want it. So let's download the file. Put it in my zip folder. Let's extract to. Oh wait, cancel that and get in here. Extract. I'm gonna put it on my desktop real quick. Not downloads, desktop. There we go. Hit OK. So that got extracted. Now we can go here. Go to file like we normally do. Let's go ahead and get our stuff out. So unhide by Alt H. Deselect everything. Z to see everything in real colors. File, import, STL, and then we go to my desktop, and there it goes. Now it's going to be super small, guys. We'll bring it upward here so you can see it. So if we go to this front view here, you can see the grooves on this bolt. They're not going to be exactly the same as the one that we're going to be using for our lead screw that pushes the bed and the X and the Y and all that stuff around. So we're just going to go into edit mode now. So I'll hit tab, and then we'll hit wireframe mode. Hit A to deselect, B to grab, and we're going to just grab all these vertices right here. And then we'll hit X to delete them. And we'll hit delete vertices. And we want to see frame. Well, maybe I didn't need to delete all the vertices. Let me see. Because we want to cap this off, so trying to figure out what would be best solution for this guy right here. So if we do wireframe mode again, maybe if we just delete this vertex here. Oh, okay, hold on, because I don't have vertices select. There we go. So hit B, hit X, delete vertices. There we go. So it left this portion right here. So the reason why I wanted to leave this portion is because we're going to, let me just zoom out a little bit because it's making things difficult. So the reason why I wanted to leave this portion, so that way we can, oh, how you doing, man? Great, I'm glad you, stopping by. I think it's Global Rack. And so yeah, what I was saying here is the reason why I deleted the other vertices. I don't know if you just seen it, so I'll just undo real quick. I deleted these vertices so that way I can actually close in the gap. So if we delete here, you can see right here we can actually close this by pressing F to face when we select them. So if I hit Alt and then that ain't gonna work, is it? Nope. Okay, so it wants to be a little difficult. So number pad, control 3 on the number pad will get you on the left side view. So if I do C, that'll help me just grab. All I have to do is just go around this area. I don't know if I'm grabbing the other vertices though. Hold on. A, and then we'll do C. And just touch these vertices right here, because we're not trying to grab these guys down there, so I'll have to hit the enter. See, we grabbed too many. If I zoom in, maybe that'll work. Okay, so zoom in. Oh, I know, I got an idea. Hold on. Yeah, there we go. Because if we like search kind of the top, we'll be able to see the vertices sort of here. So if we hit C, it'll keep us from touching these vertices down there basically. And let me see if I can do the alt. Nope, it won't let me do it. It's being a pain. I wonder if I could do it inside. I'm trying to do it where it can do like quick, so you don't have to try to hold all the information really fast. And I think I have an idea. So wireframe mode, yeah, there we go. If we hit B to select, and then we just grab these first vertices right here, I think that did it. So let me hit Z again, and we can double check it. So yeah, we grabbed them all except for we need to deselect these two. And then if we, I don't speak English, but I want to look, you're the best work. Oh, and thank you. I'm not sure, I guess you speak Russian. I'm not sure how to say thank you in Russian, so but yeah, definitely check it out. I have my mouse up over here that you guys can see. It'll show any information of any buttons I click, so if you don't know what I'm saying, at least you can kind of see what I'm doing on my keyboard. But yeah, so now if we hit F to face here, if I just grab it, there we go, F to face, it'll close that gap. And then if I grab these corners here, oh, not that one, not that one, why is it doing that? There we go. And then if we delete those with X and then delete vertices, that actually would have closed off the information. So now we have like a lead screw that only has the end piece. Instead of having that bolt that comes out, we just have a circular end, which will allow us to, say, technically mount a motor to the shaft with a cullet or a motor connector is a hub. I don't know how to explain it. It's basically the same thing you do for lead screws for 3D printers. They have a connector piece that mounts it to here with a shaft. Anyway, so now we have that. We're going to double check our normals. I want to see if they're backwards or flipped in the wrong direction. So how you do that is you go to display. And if you hit, we'll do face normals because it's easier. And now you can see the normals right here, but they're not all that well to be viewed. So what you'll have to do is actually move them out so you can see which way they're going. So you can see if they're going outward, that's good. But you see this normal over here, it's not doing so. Right here, this one. So the one we just closed off the gap for, this is not shooting out the way we want to. It's actually going inward. If I hit Z, you can see that the normal is coming outward. I mean inward. We want it to go out around like the rest of them. So if we do put color or anything on here, then you won't see the color because it's kind of inside. It's doing an opposite direction. So we have to invert that. So if we do, we already have it selected. As long as you have it selected, so I'm gonna hit Z. So if we select this one here, and then we hit I believe it's Control N, if I'm not mistaken. There it goes. Control N will pop that vertice out, so it flips the face to where you can see it. So now you see it's pushing out instead of going in like it was a second ago. So now we can color it however we want. So say if we want to make this lead screw black or something, we can do that. So we have that. All the other vertices are actually showing outward, so that's good. We can remove the normals now that we know which way they're going. Go back into, I want to say, let's go back into object mode by hitting tab. Now that's the screw, and we want to make sure we extend the screw, right? So we have multiple options here. We can go back into edit mode here, my bad, edit mode, and then we can stretch this out sort of, but honestly what I'll do is I want to, let's go to top view here, 7. I'm going to put us back into wireframe mode, deselect that face, hit B to grab all these vertices right here that starts off at the front of that shaft. So then if we hit Control D to duplicate, hit X, and then just control and drag it over, you can see that it will kind of match up. It's barely matching right there. So like if we put it right here, that looks kind of matched up. We're just trying to make it look kind of normal here. So if you can see it, it's not connected. That's the only bad thing. It's not actually connected with this lead screw here, because we didn't like pull and extrude it out. Because if we did an S small, can you evaluate my small works? I'm not sure what that means. Do you mean like check out your? Do you have videos? Is that what you want me to check out your designs? Is that what's going on? Because if you do, I don't mind checking them out if you have like a YouTube channel or something. But yeah, I don't mind looking at them. And but yeah, what I was trying to say was these aren't connected, but that's okay because we're not gonna print this out or anything. We're just using this information for our CNC machine that we're designing. So I can, duplicate that as many times as I want. So now that we moved it, if we go back into top view real quick so I can show you, I'm gonna do 7. If we just hit, if I zoom out a little bit here, if we hit Control R, I believe it is, we'll duplicate, or no, it's Shift R, my bad. Shift R duplicates the same exact information we did. So Shift R, Shift R, Shift R. So now you can see it's getting longer. And then, so we just hit Shift R a few times, it makes our lead screw really long. And then if we do object mode here, you can see that our lead screw got really long, and it actually looks pretty well made. It doesn't even look like it's not connected. So this is just to fool your eye, but it's not going to fool the system. So if you were designing something to print it out, you will not be able to do it that way. You would have to, it depends. It's one of those things where if you know what you're doing, then yes, you can do it this way if you want to, because in some slicer programs you can actually import objects and then make sure that they slice together instead of separate parts. So if you slice them together, they group together like you already grouped them in here instead. So like I just found that out for Cura, for instance, has that ability. So I will be streaming again here for like 2 more videos today, because I wanted to talk about that discovery. Because I'm with this robot that I'm building, the 6-axis robot arm, there's gonna be the wheels. The wheels are gonna be Mecham wheels, which I did a previous video earlier about it. But those wheels have these rollers, right? And I'm printing out those rollers in flexible filament. And the flexible filament, you have to print out usually one at a time, really slow, no retracts, all kind of stuff going on, right? But I figured out how to print them out through Cura, where you can print one at a time, all at the same time, basically. So it's like if you have your build plate, you're printing out one in one corner, another one in another corner, another one, so all 4 corners, or like all, like if you, however many you want, basically. But they print one at a time, like if you were to import the file over and over again, but it does one at a time during the whole print, so you don't have to keep getting up, going to push print and redo the whole print all over again for one. You can actually just do it for all of them. They'll just have to print one at a time from each other. So I'm going to be making a video here shortly about that, but in the meantime we'll go ahead and finish this up. So yeah, we have our lead axis screw now. So we can do, again, if we wanted to go to Thingiverse, we can grab a file for a NEMA 23 stepper motor. I'm pretty sure somebody would have designed one by now. NEMA 23. And then we would just have to import that motor. Oh, they got a spacer. That's pretty good. I may have to use that. Let's see. No. Oh, they got... Yeah, they have one design. It's a circular motor. I don't really like it because mine are squared. I'm trying to make sure mine look the same. So I'm trying to figure out if somebody designed one already that's fully designed really quick. No. If I don't find one, I mean, I know I already designed one myself. Oh, here we go. Yeah, here they got, somebody got one. So that's good. It's just a mock-up, which is fine. Yeah, I designed one myself on one of my other Blender design files. Especially, it's the exact same. Matter of fact, I wonder if I could pull up Blender twice here. I don't know how well this works, because I never did this before. So I'm going to see if I can pull up another one. Well, I know we only have one window, so you guys can't see it. Let's NEMA 23 blend. Yeah, there it goes. So this one is basically mine. I know you guys can't see it, so I don't know why I'm saying this one. Hold on, let me just... What I'm going to do is I'm going to export it as a STL, then bring it into the other one that I'm working with. So STL, we'll call it NEMA 23, goes in the documents good, so that's good. We'll close this out. Now I can go here, File, and then we'll go to Import STL. This is the exact size of my stepper motor. The only thing is it doesn't have the grooves that for where the bolts are mounting at. That's the only thing. It only has the holes, I think. But let's see, where is it at? 23. Where are you? NEMA 23. Here it goes. So now we have the NEMA 23 stepper motor. If I bring it up, you can see it. So that's the same exact ones that I actually own right at this very moment. So that's good. So if we do front view and we want to rotate this 90 degrees, we just have to hit R to rotate and then hit 90. So if we go up, drag it up. That's a little too far up. We probably have to zoom in a little bit. See, when we start zooming in, you can see the other squares inside of this square here. That allows you to get more finer movements. That looks okay. It's not the best, but that'll work. And we drag it back. Probably have to zoom in a little bit more here so we can get this one flush. I won't do it. I'm gonna have to just eyeball it, I guess, which is fine. Z, and then we can just drag it up a little bit just to kind of match. See, because this is an 8mm shaft that I have for mine, so I would have to make a coupler. That's what the name of it is. I'll have to make a coupler that mounts this shaft right here to this shaft right here. That's gonna be 8mm of a hole in diameter. So if we move this back a little bit, we'll put it like right there for now. That's fine. But see, now if we look at, we'll have to go to the top view and move it back a little bit here so it can match up. Right there looks pretty okay. So yeah, so if we see that, that's our lead screw right here. So that actually will work pretty good. And if we grab both of these parts together, then we go to top view. So I had to hit shift and then click on them. Then we'll do a rotate by 90 degrees. And then if we move back here, it's about there. And then we want to move over just a tad to match up. There we go. That looks pretty good for the most part. It's not dead center. I can move in a little bit to kind of center it a little better. There we go. Move in, then we can just control and then drag over. That was just like a millimeter off. But yeah, see, now our lead screw would actually go all the way through. We need to make sure it goes all the way through, so I have to click on this one again, go back into object mode here, and then I don't know if I can duplicate that again the way I wanted it to. No, it's not allowing me to, so we'll do where we have to duplicate and just drag forward a little bit. So zoom in, we'll hit Control D, and then we're on the Y axis, so we'll hit Y and then Control and then drag it forward. So that was too much. We can do right about here. That looks good. Now if we do that again with Shift R, I mean, that'll move it forward, forward, and forward. And then if we do it again, it'll pass. But that's fine. I don't care if it passes. That's not a big deal to me. I'm not sure about everybody else, but it's not a big deal to me right now. But yeah, so if we see now, if we go zoom out a little bit, now our motor is connected, and then the shaft goes all the way out, which we can grab both of these and then move it back a little bit, because that motor shaft right here is a little whatever. We can just move it back to where the lead screw matches up right here. Really, once we start moving the bed back and forth, we want to make sure there's clearance, because what's going to happen is, say we move our bed all the way to the back. Well, depending on where the motor is, our table can bump the top shelf of this motor right here. So we want to make sure that there is going to be enough space in between for the clearance of the motor. So I'm going to drag this down so we can see really quick. I'm going to drop right about here. So we already have both of them selected, so all I have to do is just pull down on the Z-axis. So that looks kind of high, I'm not gonna lie. I'm gonna have to zoom in a little bit here and bring it down some more. So that's a little too much. I'm gonna have to zoom in a little more here. That's good, and then we can just drag it slightly. There we go. But you can see that the bed is gonna hit my motor. So like, say when I go back to top view, zoom out a little bit, sorry about that, and I don't know why this is all the way forward. Let me just go back forward a little bit. There we go. So then we have something. So when we get the pillow block in there, you'll see what I mean. But now if we deselect that and hit Z, because we're going to have to grab these parts again. So this one, this one, this one, and then this guy over here. Not that one. Shoot, that one. Yes, not. God, I hate when this happens. Ugh. Deselect it. Grabbed. Why wasn't that clicking? Zoom in here. Grab. No. There we go. So, gotta make sure I'm grabbing this guy. Try to do this kind of quick, guys. I'm sorry if it's taking too long. Shoot. There. Let's just grab the back ones first, and then we'll grab the front ones next. See, I have a mouse that has like a infinite scroll wheel on it. It's that Logitech one, MX something. I forget the name exactly, but love it. It works out great for this type of stuff here. Okay, and there we go. So now we have all four. Grab this guy. So when we move our bed, we are going to pull it back, and then see right here is going to smack against here. That is not a good sign, because once we line them up, it's going to hit right here. We don't want that. So you can see, it's kind of hard to see, but I'm going to change the color to black for this so you guys can see it better. We go right there, new, diffuse, we'll just bring it down to black-ish color. It's like, not all the way black, but kind of black. There we go, that looks good. So see right there, it would hit. So we need to make sure that there's clearance between the bed and the stepper motor. So for one, there's a bunch of ways to go about it. We can, obviously we can get 20 by 40 extrusions up here to allow the travel back and forth, which I already have, because right now the bed that I have on that machine actually has a 20 by 40 on it. So I can see why I did that in the first place. But I don't know, guys. I don't know how we should go about that one. It's one of those things where I'm like second guessing, but for the overall, well, at least we can see where we're at. So if we need 20 by 20 or whatever, we can do that. So if I just duplicate this one, because I'm going to wind up having to buy more, obviously, rails. So I mean, that's not a big deal to me. So if I do duplicate this, let's go to the top view, hit D to duplicate on the x-axis, hold control and just drag it over to this one. And then if we go down to front view and then we drag it upward, that matches to the top. It's a little off compared to the other one, which I'm not sure why that is. We can move it over one. There it goes. So if we basically we'll have to bring the table up a little bit, but it will still work. I mean, we can bring all that up and that'll give us clearance to where the stepper motor won't get smacked in the back there. So we can do that again where we're duplicate this one. So this is what I'm saying is like when we're doing stuff like this, you gotta see what you need to buy. That's why I'm doing it this way, because if I don't see it, I can't really, you know, design it. I mean, sure, I can probably like draw it up with a schematic doing like drafting, but that'll just it'll be easier to do it this way because it's quicker. Shift D to duplicate this one, and we'll just drag it over to that one, and you see it's not the same level. So if we delete this one that we don't need now and delete that one, and then our track is in here somewhere that we gotta grab because we gotta bring that up to the top. So this track and this one right over here, I don't know if those are all connected or not. We'll see. Yeah, they are. So if we bring them up, I can double check the height. Yeah, that looks good. And then if we grab this one, hit Z. Did we grab both? Yeah, we grab both. That's good. So we have to grab this guy too, and this guy too. See, front view, and then we drag it up just to reach the top. Good, and then we can drag this up to reach the top. So now we have clearance. You see how adding a 20 by 20 gave us enough clearance to move it. Now, if I'm designing this and I want to have stronger rigidity, I would probably do a 40 by 40 instead of 20 by 40. So that way I'll have more instead of it. Me personally, I just know squared thickness would be perfect for something like this. So I would wind up probably buying me a 40 by 40. But for right now, what I have is 20 by 40. So I'll just stick with this for now while we're designing this. But if I go back, I'll just redo it and just duplicate and make a 40 by 40 instead. But so yeah, now we have clearance. So if we go to the back of the design here, the table will have enough gap here to actually miss the motor. So there's a gap right there that allows us to miss. But remember, we're going to be adding a pillow block and a motor mount and all kind of different stuff on here, so it's gonna be still maybe close to touching, I don't know. So for now we have to go ahead and start designing the bracket that holds this motor to this frame. So I'm gonna get the one that I bought offline right now. I'll get the dimensions in. So if I go to eBay, that's where I bought my stuff at, and go down to the bracket that I have. I'm hoping they have the dimensions on here that I can see. Let's see. I mean, I can import the design, the picture, and we can kind of model it off of that using my NEMA 23. Because I don't see they don't have a design schematic of what it looks like other than the pictures. So what I'll do is I will import this image. So I'm gonna just do save image as NEMA 23, and then it downloaded, so that's good. So we can import the image. So now we're gonna add another image, which is kind of ridiculous to have to do, but we got to. There's no really other way. I want to make sure that I'm kind of lining everything up for the most part. So if we go down to open, and then I think it was in downloads, no, maybe pictures, NEMA 23, NEMA, God, there's so many pictures in here. There it goes. So now we have it, but you can't see it yet because it's not visible with this one in the way. If I go up, turn down the opacity of this machine that we don't need, it's in here, right here. You just can't see it because it's so small. So if I want to scale it up, though, we can do that. So all I have to do is grab here and then push. So that's the bracket that I brought. It's pretty decent looking. I like it. Bring the opacity up. So what we can do, we can duplicate our motor and then flip rotate it to where we can see it. So I'm going to hit D to duplicate it. We'll do it on the Y, drag it forward. And then we'll do 3 to get the side view, hit R90 to do top view to make it flat. And then we'll go 7 to top view again, and then bring it down to match this picture. And what we could do is just hide everything else. So if we do, I'll hide this guy. Let's just double click everything. So AA to grab everything, and then I'll deselect this one, and then we'll hit H to hide, and then we'll bring this one down. So if we bring it down to right about here, we can kind of match it up with this mounting holes that I have, or these mounting holes that I have. So I'm bringing down a little more. So you see we need to scale it more on the picture. So if I do this right here and just bring it out a little more, we're trying to get it up, get it to match up. So I think right about there would do it. We'll just bring it up. So that's kind of close. It's almost there. Let's bring it down just a little bit more, or bring it up a little bit more right there, I want to say. And bring it up. No, that's too much. I have to zoom in a little more, and then pull it about here. And what if we stretch it out a little more? See what it does. Okay. Okay, that's not too bad. Yeah, I don't mind this one. So that looks pretty good. So the mountain holes will be pretty much alright. So it seems like that'll work for it. So it goes all the way through. So if we, obviously when we start designing it. So what we'll do now is we'll go into, we're already in object mode, so that's good. We're going to do Shift A, add a cube. There goes a cube right here. We want to change the dimensions of the cube, so we'll go here to dimensions. If this is, I think this is like 57, well, let's just try 100 on the Y to see if that'll work. So do 100 to start off with. It's a little overshot. We can do maybe like let's do like 90 millimeters. A little too much. Maybe like 95. Okay, so like 98 maybe. A little too much. Okay, so it's probably like 97 or 96. Let's try 96. Okay, good. So 96. And then on the X, we can scale it out too. So I want to say if that's 10, 20, 30, 40, 50, 60. We'll try 60. Perfect. So it lines up good. That's great. And then it's 2 millimeters thick. I'm not sure how thick my plates are. I don't know if because it didn't give me dimensions, so I'm not sure if it is. I feel like it would probably be about 3 to 4 millimeters thick, since I'm looking at these pictures right now. So we'll just do 4 for now. It really doesn't matter too much, but we'll do 4. Bring it up to that. And then we have to go to the front view here. I'm on front orthographic mode because we have to drag this guy up to the front, bottom line here. There we go. So now we have that, we can bring this guy down a little bit here so we can match everything up nice. And then go back to top view because now we need to start designing these curves here. And then we need to bring the holes in and all these holes. So what we're going to do now to get this, now this is really precise measurements, guys. This isn't where like you're designing something in Blender's weird world of measurement, I guess. It has Blender units, but this is actually real life world design information. So anything I design in here, if I printed it out on a printer, it would be for real whatever it is that we're designing. So that's what's good about how I'm designing right now. I will know exactly where these parts need to go and everything once the design is fully over with. So if we go here and click and go to object mode, now we have our vertices. We're on faces. We need to go on our edges, and then we're going to deselect everything. I'll just go here, Z to get out of wireframe mode. Then we're gonna click on this one, move over, click on this one, move over, click on this. Nope, not that one. This one and this one. I'm sorry about the noise in the background, guys. My daughter's just getting mad at her brother. So then if I hit, I think it's Control B. Yeah, that'll give us a bevel. If we just pull out, see how it's, there we go, pulling out a little bit. Now it's kind of hard to see. If we undo that, go back into top view, because already we still have those edges selected. So if we hit Z, all these edges on the edge are selected, so that's good. So if we go down a little bit and we hit Control B again, we can pull it out just enough to kind of line up. Now it may not be exactly lined up perfectly, but it'll be lined up enough. Now if we scroll up on our wheel, it'll give us another vertice on, or another edge. So we have one edge there, 2, 3, 4, 5, 6, and if we pull back a little bit more, we could kind of try to line it up as best we can. It's one of those things where you kind of have to play with it. I mean, I know you can find out the radius, I believe is what it is, and kind of like compensate for that, but honestly, I don't know what this radius would be because they don't have any information on it, so I'm just having to do this myself here. So right there looks pretty good. Even if I added a bunch of vertices, it's not gonna do much. So if we, you know, go right about here to kind of line it up, that's not bad. It's really close. So I mean, literally that's probably like 0.001 of a millimeter or something, but that looks like it came out pretty good. I mean, just compared to us, you know, just, you know, doing a bevel and everything. So now we can go ahead and start getting our holes put in. So if we do, we have options. We can cut these holes out inside of edit mode, but the better thing to do, I feel like, would be for us to just boolean these out. So we'd have to design the holes or the circles ourselves and then put a boolean modifier on here. So we'll do tab, and then I will do Shift A, do a cylinder, and there goes the cylinder. It's really small to see, but if we go to here, I don't know what these holes will be. I think they're like 5 millimeters for my mounting holes on here. So if we do 5 and 5, I think that would match up. So if we drag down here, move it over, too much. Let's zoom in a little bit so we get finer tuned here. Okay, so we're just gonna have to manually do it with our eyes. There we go. That looks pretty good. Good. So if we grab that and then we just duplicate, so D to duplicate, on the Y, we'll bring it up right there, and then if we grab that one and this one, and then we duplicate both of those and drag it over on the X, and we can move it over to right there, and then now we have 2, 4 circles that'll be able to cut out. We're gonna have to change the height. We can change it to anything because we're using it to cut this out of our part, not actually making it into a part. So if we do like, I don't know, 10 or 20, that'll be enough to actually cut it all. So we'll do 20 on this one too, 20 on this guy, and then 20 on this guy over here. And then all we would have to do is cut it out. But I'm not going to cut it out just yet because we want to get the other circles in. I want to be able to just pretty much cut everything all at once. So we'll do shift duplicate for this one, drag it over just a tad. I want to say like right about there, and then we bring it down right about here. We have to move it over just one more. Let's see, can we bring it up a little bit now? Move it over one now. Okay, so right there looks okay. Get up to about right here. And I'll just move it over ever so slightly. Okay, so that looks pretty good there. And then I'll bring it down to about the center of the design. The reason why I'm doing that is because we're going to pull and extrude that circle out. So what we're going to do is go into object mode now. Edit mode. And then we'll go down, zoom in. We're going to do our vertices individually. And then all we have to do is select. So if we do A to deselect, B to grab all these vertices right here, bot select. Then all we have to do is pull these down, and that'll drag us out. So you see it kind of did well. We just have to pull it back just a tad. And then same thing with the top. We can do A to deselect, B to select, and then we can pull this one up. So we just have to drag up on this one, and there you have it. So now we have that one selected. So if you go out back into object mode again by hitting tab and then shift D to duplicate, then hit X to do it on the X axis and move it over, we have one there. And then if we hit control shift R again, and again, now we have all of those holes ready to be cut out. And now we just have to get this one big hole. I'm not worried about this because what these holes right here are for are actually for our NEMA 17 stepper motors. So this plate can hold NEMA 17 or NEMA 23. I'm using NEMA 23, so I'm not worried about this. I'll just cut out the hole for the 17. So we're going to do another A to deselect. We're going to Shift A, add another circle, well actually cylinder, and then we're going to pull it up over here to about right there. We're trying to make sure it's centered. Like pull it right about here seems pretty good. So if we do, I don't know, I think it was like 30 maybe 30, and nope, not 30, so maybe it's like 40, or it could be 40. Let me see, 40, yeah, a little off. Let's just say like 35 maybe, or 38. Let's try 38. Yeah, there we go, 38 by 38. So now we have that, and then we can change this one to 20 as well, so we can cut it all out. And there you have it. So now that we have that, we can go ahead and hide this guy too. So we hit H, and then if we hit this button, we can see all the parts that need to be cut out for that bracket. So what we'll have to do for this, we'll go into tools here, and then we'll have to do where we're grabbing all these. So see, once we hit it, you can start seeing bowling information. My bowling tools have been down. All you have to do is click this and you can see it. So if the last thing that we grab is what they're gonna cut out of. So if we grab this guy first, this one next, that one next, that one, this one, this one, this one, this one, and that. Oh, wrong one. So this one, this one, this one, this one, this one, that. Oh man, I keep messing up. I'm sorry guys. Hold on, I'll do this pretty quick. This. Come on. Grab that one. It doesn't really matter which one you grab first, I don't think. We're gonna test that theory out, but for the most part, that should do it. Now all we have to do, if we're doing a brush, if we want to see the holes before we get them cut out, we can do that by hitting difference here instead of doing it difference here. The brushed one will show us the holes before we cut them out, and then all we have to do is hit apply. This will already apply it if we hit this button. So if we hit difference, oh, we didn't grab the last one. Hold on, my mistake. Remove all. We gotta grab this last. Now we can hit difference. There we go. So now you can see all the holes that will be cut out, and it looks pretty good. I don't really see any problems with that. So if we just hit apply, now we have our bracket made. And that's the same as that bracket that I just bought off of eBay for like, I don't know, $10 for 2 or something like that. I mean, it's coming from China, but see, this is where I'm trying to get at. Now, if I wanted to, I could design and 3D print all the parts I want. The only bad thing is they're 3D printed. So, one, there's not going to be a lot of longevity in there. It's going to have too much harmonic interference when it comes to the harmonic resonance. So, there's going to be air in there. I mean, even if I did 100% infill, the motors are going to tend to get hot when they're cutting, so that could melt the plastic, and then over a period of time, it's going to mess up your prints or your cuts or whatever, so you're going to wind up having to replace it anyway. So that's why I went ahead and just bought the aluminum cutout. But, I mean, you have options. You can 3D print this part and then, you know, use it if you want to, or even use that 3D printed part to make the same part out of aluminum yourself if you have the tools to do it. If you can cut the aluminum using like a jigsaw or a regular saw or a table saw, whatever, some kind of saw that will cut out the square part of this. I would recommend a jigsaw or like a bandsaw so you can get those grooves in if you're trying to get the grooves. And then these holes, you just need to drill them out with, you know, a 5mm drill bit. And then all you have to do is just like cut through here after you drill the 2 ends, and then like deburr it out with like a tool that basically cuts and shaves off the sides and the innards. But so you have those options if you have those tools, which will save you some money, depending on if you already have the materials, so say like the aluminum or whatever. But so yeah, so we have the plate now. We can unhide everything, and we can bring this plate up so we can see. So Z to see everything. Bring it up on that view. Bam. Too high. Zoom in a little bit. Drag it down. It's about here. Okay, so now we have the plate that'll work for our motor mount. So that's good. We got that done, so that will help out a lot when it comes to everything we're trying to do now. So if I do zoom out, we're gonna have to duplicate this plate a lot. Well, not a whole lot, but at least twice. So, or actually once, because we're duplicating, so it's copying it one time. But so if I drag this motor, we don't really need at the very moment. So I'm just gonna hide it because I'm gonna need to place it on my X here soon. So I'll hit H, and then if I do a duplicate, so Control D on the Y, drag that guy back. You probably can't see it. Drag it back some more. Go into this view, and then we're going to rotate 90 degrees. Okay, wrong way. Negative 90 degrees. Rotate negative 90 degrees. And then if we did that, it should line up pretty good. We just have to pull it out a little bit because it's too far in. Oh, my mistake. Right there is fine. Oh, not really. I have to zoom in a little bit. Let's get that. Good. And now we just have to drag it down to mount the holes up. Too much. Drag it down right about there, right? I feel like that'll work. Let me see. No, not at all. Let's drag it up a little bit. One, there we go. So those holes will mount just perfectly flush with the holes that need to be mounted. So you can see it works. And now that we know where that is, so you see there's still a gap between here and here, so we're gonna have to grab this guy, shift, grab him, and this guy now. and 3, and then we can pull it to match up right here. Zoom in a little bit so we can see. 1, 2, done. Bring it up a little bit because we need to go on our back view side so we can see the plate. So if we do 1, and then we'll do control 1, that'll give us back view so we can see if it's going to mount correctly. So we would need to drag this up a little more. There we go. That will allow us to put 1 screw here, 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 and here. And if we want to do a middle one, it's fine, whatever works. But we have it now. And then that gives us enough clearance to put our screws in right here and at the top. But now you can see the bracket is not all that great because we have this in the way still. So we would need to go even higher than this, unless we decided to shiv this off, say we cut some or something. I mean, we can bring it down a little bit, yeah, but that's not going to give us enough to clear this table. So when it comes to that, we have to obviously get the table cleared. So we can do, I think for sure, I know for sure they have a 40 by 80, I think, or 40 by 60 aluminum excursion. I can double check this. I have eBay up anyway. So if we do a 40 by 80, I think 40, 80 aluminum, right? Aluminum. I don't know if I'm spelling that right. That 80 by 20. Okay, so that's not gonna work. What if we do, I guess an 80 by 80 would probably be better. 80 by 80, so we have, so yeah, they do have it. It's, oh, that's a T slot, that's not the bracket. Okay, here we go. Wow, this is actually a lot. $109 for one. Well, here goes one for 25, but it's 80 by 80, and it is 305 millimeters long for $25. But we would need something longer than that. They got a, wow, they have 12 20 millimeters, so 1,220 millimeters. That's pretty long for 80 bucks. Really, we only need about, what was it, 800, I think. They have a 915, which wouldn't be too bad. I mean, granted, I can use like a saw to cut them if I needed to, but I try to get them already pre-cut at the size that I want, so I don't have to worry about cutting it later. It makes things a lot easier for me. So yeah, if we did an 80 by 80, I mean, at least we can buy those and have that implemented in. Here goes at 600, 610. Yeah, I'm not sure. They have a lot though, so we could change it. So 80 by 80 would be 2 of these stacked on top of each other, basically. And then the center, so we would have, because this is 40 millimeters, so it's another one stacked on top. Now, I don't know if they have a 60. I'm pretty sure they could. I don't know why I couldn't find it. A 60 by 80 or 80 by 60. I don't know which way they would do that. Usually it's the small one first, because like 20 by 40. But I don't see an 60 by that. Right, because it'll be 40 add 20 is 60, yeah, so because they usually go in 20 increments. So I'll try 80 by 60, see if that pops up with anything. No, I don't see it. So yeah, it would have to be 80 by 80 then. Which is fine. I don't mind. I don't really I don't care how, I mean, the thicker the better. And then in the innards there will probably be, I'll probably have to put some like I want to say epoxy granite or epoxy resin, something inside of there that helps hollow out the shell of it, because we don't want any harmonic resonance that will cause issues. So what I'll do is we'll duplicate these two, drag those up, and then make it into what we need. So we'll do Shift D on the Z, bring it up, and then we'll do Shift, well, actually no, Shift D. So we'll grab both of those, hit Shift D on the X, move it in. And then the same thing on this side, Shift D on the X, move it in. I feel like that's wrong though. 80 by 80, right? This is 20, 40. Okay, so we have to do that over again. So R, that's 60, that's 80. So that's what that would look like. Wow, that's a lot. We do Shift D, X, move it over 2, and do it again. R, that's, there we go. So the inside of this block is hollowed out. So on the extrusion, so we can't see that on here because I'm duplicating these extrusions, but that will be hollowed out, and we would have to fill it in with something. But that'll work. We just need to grab all those and bring them up now. But see, now we're getting higher, and that means our gantry is going to have to be higher up too. So really, once you start doing this, at this point, it's probably better for you just to do all 80 by 80 excursions, because then you're adding more height, and these excursions on these sides aren't going to be as tough as this, and then you're just like, well, at this point, you're just going to go for broke and just buy all the 80 by 80s. But we'll just go ahead and start duplicating these. Not duplicating, but dragging them up. It's right here. It's hard to see. I don't know why I can't see my Z right there. Where is it at? Where are you? Oh, okay, there it goes. Sort of. There we go. So just drag it up. Let's see. Front view. Okay, yeah, that looks good. And then we need to grab all of these and then drag those up too. So grab that guy and this guy. Nope. Nope. Zoom in a little bit. You and you need to go up. I think that worked. Yep. And same thing with the other side. This one and this, nope. That one and that one, nope. Come on. Why are you doing that? It's like you're deliberately trying to grab nothing. You. There. God, that was stupid. Okay. So if we go back, we can see that they line up good on the table. Now if we bring our table up, perfect. Now you see we're, bam, hitting, our drill is gonna like plunge right into the bed and destroy everything. But at the moment we can move that around too, so I'm not too worried about that exactly. So if you can see here, we got the lead screw that'll come out with the ball. We'll have to get the ball bearing pillow block thing in. But yeah, so this is gonna be if we had to do it this way. Now if we had a smaller, like if it was just an EMA 17 motor, then we wouldn't have had to drag it all the way up to be this tall. But it may, I mean, really it's probably better because then at least you're having more rigidity. I don't know. It's one of those things where it's what you have to spend and what you're wanting to do. Always keep that in mind. And then since we're on the outside, I'd rather have it like in the center here. Like I would move this to here, but that's touchy because when we start drilling, I mean, we're gonna have a waste board, so I don't see that being really a problem. But I don't know. It really just depends on how you guys ever feel about whatever you're doing. But now that we have that, though, I'll go ahead and move this guy over. Oh, wrong one. Nope. Control, move it over to about here. Go to this view. We're going to rotate -90. Top view, rotate 90. Side view, rotate -90. And now we can see, I probably did too many extra steps of the rotating, so if you guys are watching and you want to talk your noise, you can go ahead and do so. But yeah, now that we have that, we can kind of match this up, and then we drag this guy up to like right here somewhere or something. And then we have our design, so we need to move this guy over just to match up right there, I think. Oh no, it looks like a little too close. Yeah, it's a little too close, so we have to back it up a little bit. Back it up 2. There we go. So that will sit flush against the side. And then all we have to do now is get our other motor that we hidden. So Alt-H. And then we'll grab this guy, go to top view so we can see where he's at. And we'll just drag it over. So right about there. Front view, bring him up. So right about here. Then we're going to do a rotate on, I don't know if that's negative. I think it is -90 degrees. Yeah. -90 degrees. Bring it up again. About a little too far. Zoom in a little bit here. Drag it down to right about there. If we could do Z, find out where we need to put it at. Right about there, I think. I don't know. It's hard to tell. I feel like that would work. I'll just back it up. I don't know if it's flush. No, it's not. It's too over. I have to pull it forward a little bit. Let's zoom in. Pull it forward just a tad. And that looks good. See, we can see all the way through to the back. So through the holes. Alright, so now that we have that all good, you can see it goes through nicely. So if we had that bolted down, then that's where our Z-axis screw would be, just like the picture that we have that I could show you really quick. So if I do, where's that picture at? That's NEMA 23, so we don't need that. We can hide this guy. Close the eye. I don't know if this is it. Is this it? Let's do 1. No, that's not it. This is it right here. So this motor right here is going to be this motor right here. See? And that's the same bracket we just designed and put up there. So we're making some headway, guys. I know this video has been kind of long again, but it's obviously there's a lot going through it, trying to figure out how we're designing this machine and what we're going to do with it. And so it takes some time and there's a lot to cover. So I do appreciate you guys taking your time to, you know, be here with me on it. And this is just me moving this up a little bit because obviously we need to make sure we clear that lead plate. But yeah, hope you guys are liking the video. Please like, subscribe. This is part 2 of the CNC designing machine that we're doing. And so I'm gonna cut the video out here, then we'll do a part 3 here in just a minute. I want to kind of split these up a little bit now that we're at a good place that for our design we can you know, kind of start here. So if people are kind of busy and they don't have time to like design everything right off the bat, they can pause at this point and then watch the 3rd video. So my name is Legit Lee. I like doing 3D designing in Blender. Hope you guys like to too, and if you do, definitely consider subscribing and hitting that notification button. And I'm signing out.